To begin our tutorial today, we will be discussing the different aspects and how to approach rotor devices. The first and most complicated step to understanding rotors is adjusting the upper and lower limits in degrees. The easiest way to understand this is by picturing the rotor as a compass, as in north would be 0 degrees, east 90, south 180, and west 270. From there, using the 4 points on the compass, we can align our rotor to best fit our plans. As you can see in the background, I'm adjusting this rotor right now to stop at a right angle, otherwise 90 degrees from the pointer rotor origin. As you can see, the rotor turned exactly 90 degrees and then stopped. Now if we reverse the rotor, it'll move back to the 0 degree origin point. Alright, now we'll change the upper limits of the rotor to 180 up from 90 degrees. As you can see, the rotor turned a perfect 180 degrees and has stopped. Now, if we adjust the upper and lower limits to unlimited each, the rotor should keep spinning. As you can see, adjusting the upper and lower limits of the rotor to unlimited gives the rotor an unlimited range of motion, and it will continue to rotate on its given path until the rotor is turned off or reversed. The next step to elaborate on is the braking torque of the rotor. This is the braking power applied when the rotor is turned off. For example, if the braking torque is at 0, the rotor will continue to engage on its current path of motion regardless of rotor power. So it would only stand to reason that the torque of the rotor is the exact opposite. The torque of the rotor is how fast the rotor accelerates when turned on, which leads into the amount of pressure it can generate against objects inside its range of motion. As you can see, with the lower torque, the rotor has some difficulties pushing the block out of the way. Now, let's try a design with a basic door hinge operating at a 0 to 180 degree range of motion. But first, the last aspect of rotor configuration. Rotor displacement is a relatively new feature to rotors, allowing you to adjust the height and depth of your base, which in turn gives you the freedom of adjustment along the Z-axis, so our door will fit inside of the Space Engineer's gridlock. And there we have it, a basic rotor pin door. Now for a more elaborate rotor design, here is a 4-layer gyroscope powered by rotors as a demonstration of rotor potential, with the center section as a station to provide rotor stability. Next up, we have a brief introduction to assemblers. Assemblers take raw materials and crafting parts and assemble them into block parts, ammo, or tools. Right now I have a small assembler set up. Its conveyor connected to a small cargo container. And right now I'm moving all the materials I will need for this demonstration and dropping them into the cargo inventory. Now to make sure this works, we want to make sure everything is using the conveyor system. Then to get to our production queue, we want to go into our control panel and then go to production. From there we can see all the different types of blocks we can build. Then we simply click on any of the objects that we want to build and they'll get added to our production queue there, you can see on the top right. And we can add as many things as we want in here. And your assembler will line up the production queue based on which object you're currently building. So if you have a 2 of one object, it'll go through both of those objects. and then move on to the next one. Another feature of assemblers to point out is cooperation mode. If your assemblers are in cooperation mode, then they will all be working together for the same production queue, as opposed to working individually with separate queues. After that, all finished objects will be stored in your assembler inventory. And this concludes our assembler tutorial.